Wildfires are a major issue for New Zealand. They've affected our forests and people since we arrived. More recently, we've seen major fires regularly impact communities in New Zealand and internationally, costing millions of dollars in damage. To better protect against fires, we have to understand why they behave the way they do. And to start with, we need to understand how wildfires move. Until recently, we thought that wildfires spread through radiation. Radiation is the heat you feel from the sun, or when you stand near something hot, like a campfire. We thought that the heat from a wildfire would heat the fuels ahead of it, and they would burst into flame, allowing the fire to spread forward. The trouble is, when we try to make a fire spread using only radiation, it spreads very slowly, or not at all. So how does fire actually spread? We believe that wildfires spread through a process called convection, with radiation helping it along. This combination of convection and radiation helps fire move much faster than it would with radiation alone. When fire is stationary, like in a campfire, the convection process is relatively simple. It begins with fire heating air, causing it to rise up quickly. As this hot air rises, it pulls in fresh, cold air from around it, feeding the fire with oxygen. This hot and cold air forms a loop, allowing the fire to be fed with oxygen and causing the familiar dancing flames you recognize in a campfire. When a wildfire begins to spread in a wide line, a unique pattern forms. When viewed from above, we see alternate fingers of flame reaching out along the ground ahead of the main body of the fire, with tall peaks of flame to either side creating a peak and trough pattern repeating all along the fire front. These fingers of flame are caused by heavy, cold air being pulled into the fire, then accelerating along the ground and pushing the fire forward into new fuels. As the cold air is heated, it begins to move upwards as well as forwards, forming a peak. As this new peak forms, new fingers begin to push forward on either side of the new peak, continuing and repeating the process, causing the fire to spread in a leapfrog pattern all along its edge. All the time the fire is spreading through convection, radiation from the flames continues to warm the fuels ahead of the fire, making them easier to ignite. It is important to understand how a fire spreads because it forms the basis of how we work with and predict fire. Better prediction means we can better plan and prepare for future fires, and we can more safely respond to existing fires.